Hello, welcome back to the lectures on Introduction to Biostatistics. This is going to be the second part of the second kind of lectures. So today we discuss about the level of measurements, which relates back to the 2A, which was on variables. So if you remember from the last lecture, we will be measuring different kind of variables, and the variables will have values that will be measured at certain level, which we will see right now. So let's move on with a quotation from Albert Einstein. It's an interesting one. It's where Albert Einstein says, "Not everything important is measurable, and not everything measurable is really important." Um, you know about Einstein. He's all into numbers and everything, but he also knows that if something is measurable, it may not be important. But of course, everything important may also not be measurable. But statistics, as you can imagine, deals with numbers, and it cannot really do any analysis without really having a kind of implied measures on it. So the session objective for today is we're just going to learn about what is the level of measurement and why is it really important by statistics, and what are, of course, the different levels of measurement. So to begin with, what is the level of measurement? The field of statistics really deals with numbers, right? It organizes, I mean, recognizes numbers, and then, of course, yeah, organizes also numbers, and then has a way of analyzing them, summarizing them. We'll see very soon how these numbers really start off with being summarized. Um, in order to statistically analyze anything, it is mandatory that you assign numbers to it. Otherwise, you can't fit them into formula, statistical formula, which are really, uh, in the beginning, really mathematical formula and nothing else. But math, of course, is all about numbers. Quantitative research, as you've heard in the first lecture, is all about numbers. Okay. So, while assuming numbers to different kinds of information, which we also call variables of interest, we see different characteristics of the number itself. So, for example, I'll start off connecting this with the very beginning of our lectures. So, in the beginning of our lectures, um, we saw that we have research questions, right? That's our interest, research questions. Let's say it's a research question that asks about gender, okay? And so it's a question such as this: what is the proportion of males and females in Toronto, for example? And then the real issue of interest here is gender as a variable, and that's the information we're going to collect. And the lectures on variables were just before this lecture. Now let's say we collect information on the numbers of males and females. The question is, how do we analyze this? Because when we're collecting information on gender, which can, of course, include a third gender aside from males and females, we would, have counts of them, right? We say male, female, female, male, male, female, transgender, male, female, male, women, third gender, whatever. But the question is, then once we have this information, these are still in words, male and females. If you put them in statistical softwares, or even if you want to put it in a mathematical formula, you can't put words and analyze them. You got to put some kind of numbers in them. So this is one kind of thing, one kind of level where the numbers need to be assigned, and we'll discuss about that. But there are other kinds of measurement which you directly measure in numbers. You don't measure with a quality like gender, for example. So, in some cases, numbers may truly reflect the numerical measure. Numbers are only used to identify sometimes a variable specific response. Do you identify yourself a male or a female or a transgender? If that is a question, then the person would say, maybe I identify myself as a transgender, and then what do you do with that word? Where's the number in there, right? So we'll discuss things like that. And examples are, yes equals 1 and no equals 0. That's the numbers we assign to words. So imagine that, let me pull up my pen. Yeah. So imagine that this yes is a response that people have given to your question, and no. Also, some people given answers and said no. Now, if we assign a yes equals 1 and a no equals 0, or we assign a yes equals 1 and a no equals 2, does the computer actually know what is the difference? Um, well, we'll find out in the future that no, that the computer doesn't actually know if there's any difference. So it's just this 1 and 0 or 1 and 2. It's assigned to these words, and that's what they're describing, and that's what they're going to analyze. They don't. They actually, at the end of the day, they know nothing else. They just know 1 and 0s or 1 and 2s. But in some cases, of course, for example, if you're weighing something like a tablet, right? You're weighing a tablet, and you're saying 0 grams. This one is completely different from a tablet weighing 1 gram. So 0 gram and 1 gram, this is an actual measurement in numbers, and as you can imagine, they have meanings, and computer, they will analyze 0 and 1 will have different interpretation of 1 and 0 here and 1 and 2 here, right? We'll get a little bit details into that later on. So let's look at what are the different levels of measurement. So there was a psychologist in 1946, Stanley Smith, who's, a brilliant guy who suddenly found out, wait a minute, there are really four different kinds of scientific measurements that one can do. So he wrote this in a journal, classifying different response options or even numbers into four different categories. And he said, some are only nominal, the others are ordinal, and then you have an interval and you have a ratio. So when we collect data for variables and use a number for the data, we are actually collecting them in one of these four categories. Okay, we have to remember that, and we'll see that it is important that we actually keep that in mind for our analysis. Okay, so let's start with nominal variables. Um, Now, remember, I've always said that if you see a term, so for example, a term here, nominal, right? You always try to see what actually this word in English mean. So this is an English word. Nominal could have many meanings. Nominal even has a meaning that's I am assuming it has a meaning that says it's not that significant, right? But also nominal could mean something to detect a noun or even an adjective. Um, for example, it's a common word to describe a noun or adjective, right? Nominal comes from the word name itself. Um, and that means it gives an identification of the value of the variable. So it's just you have here a name, and you are identifying that name with a value, and that's nominal. So if we're identifying a name, which is a noun or an adjective, then identifying them within a number, then that variable itself gets a measurement. So okay, let's give an example here that will be more interesting. Let's say we have some name of ethnicities. Okay, I'm sorry, this companies, this word needs to be ignored. Let's say ethnicities. The previous example was on companies, so that's left there. I'm sorry about that. So we have some names of ethnicities. Han Chinese is actually the largest ethnicities till date, and then we have Hispanic, and then we have Bengalis, for example, right? So you have these names, and how can you have a measurement of this? Okay, so these are at nominal level because they are coming from a name or even an adjective, and we have to somehow give a number to them. So the question is, how would statistics recognize them? You have to put them in a formula, a mathematical formula. Let's say you want to make make a calculation of the average number of Hispanic in a community. Okay. Well, that's not a good research question, but I'm just making it up. So you don't even ask questions about average at a nominal level. We'll learn that. You ask what is the proportion of Hispanic ethnicities in a community. Okay, and we got to count them, right? We count them, but when you count them, it's easy. You're doing a hand calculation, and you're saying we're even doing a tally, for example, right? So you keep on marking. Once you get a Hispanic, you just keep marking on a tally, and then at some point you have a certain number of Hispanics and a certain number of Han Chinese and Bengalis, and you add them up, and you see the proportion of Hispanic over all the total numbers of different ethnicities. That's how you do it, straightforward. But if you want to put it in a computer, how do you do that? So there are some statistical softwares out there, right? And you may know them already. You have SPSS, you have Stata, you have SAS, you have Minitab, you have EpiInfo, and different kind of statistical and data management software. But how do you put it in there? That's the question, right? Um, the straightforward way is you just assign numbers. So you assign some kind of numbers to make them recognizable to the statistical analysis arena, right? For example, you say Han Chinese equals 1, Hispanic equals 2, and Bengalis equals 3. Very easy. You assign that in a computer. The computer will always have an option so that you can do that. Okay, even you can do that even in an Excel sheet, for example, right? You can say uh, Han Chinese equals 1, Hispanic equals 2, Bengali equals 3, and we'll see later in SPSS that this is even a more straightforward issue. Um, Other software doesn't deal it very differently, but they have different ways of course, entering this number or assigning this value. But the bottom line from here, what's the take-home message from here? The take-home message is you have a variable. So if you ask yourself, what is the variable in here? The variable here is ethnicities. Okay, the variable here really is a little bit of panning in here. So here you go. This is your variable, ethnicities. Okay. And under this variable, the question was, like I said, what is the proportion of ethnicities in your community? Had different names. You had Chinese. This is not a good color to select. Okay, so you have Han Chinese, one group, Hispanic, another group, Bengalis, another group. Okay, so you have all these responses from this variable ethnicity, and you know that you are going to measure a variable in quantitative research. You have answers in words. And these are nouns or adjectives that you need to assign a number to. And here's what we did: we assigned a number. Um, Han Chinese, 1, Hispanic, 2, Bengalis, 3. Now we've had our nominal levels of measurement. These names have been measured in numbers. Okay. Now the statistics can do a possible calculation with 1 and 2 and 3, which the software doesn't know what it is. You know what it is, but it knows that, okay, I've got a number to calculate now. Okay, so the numbers are called codes. Okay, these numbers, when you enter software, they're really called, they're called codes. So if you want to remember really what nominal variable is, this is how you remember it. When you have to assign numbers or codes to the variables values to make it recognizable and statistically analyzable, it is called nominal level of measurement. That's the way I remember it. Okay, so you have response options. You have response options from a variable or a question, and you ask yourself, okay, did I really measure it in numbers? Did I say 30 degrees centigrade, or did I say the density is 2 milligram per liter or something? Or did I say the height was 3 centimeters? Or did I say the amount of money was $5? All those are directly measurable numbers. Otherwise, if I said Wait a minute, these are blue colors, red colors, and green colors. These are the options I have in my response. So I gotta code them somehow, put a number on them so that the computer recognizes them. And that's when I know it's a nominal level of measurement. Okay. If you correspond this back to our variable lectures, then you will see that these are really coming from qualitative kind of variables. So you have quantitative variable and qualitative variable, which is not to mix up with the quantitative research and qualitative research. They're a little bit different. Okay. So in the previous example of the name of ethnicity, that variable ethnicity itself, um, we had to code them, right? We had to code them to make it analyzable, and that's why these are nominal level of measurement. Now, I got a quiz for you. You can, pause the video for a while and think a little bit and answer to yourself. The question is, can you prove that religion should be measured in nominal level of measurement? Okay, you can pause the video, think for a while, and can you prove it that religion should be measured in nominal level of measurement? In other words, if I want to find the proportion of different religions in a community, then collect information and my variable is religion, and I have different response options, right? Um, those response options should be measured in nominal level of measurement, but how do you prove it? The hint is around here. Okay, the hint is around here. If this condition satisfy, then you know that this is a nominal level of measurement, and that's how you prove it. Okay, take a short break, 5 seconds, and think about it maybe. Okay, so but we'll move on. I hope you have figured the answer out. Basically, you have to you know it's a nominal level of measurement because you have different religions name and you code them to make it recognizable to the computer. Now, the next level of measurement is called the ordinal level of measurement. Okay, and how do we know what is an ordinal level of measurement? It's okay. So first of all, it's very easy because remember that all ordinal level of measurements are also nominal level of measurements. Okay, the only thing is that this measurement variable has an inherent characteristic so that the values bear meaningful hierarchy among them. Meaning, one is top of the other or one is below the other, and there's a meaningful hierarchy. Okay, so example, first, second, third, fourth, etc. Or an example that is used typically in well, it's not really biomedical science, but you can say it's in a domain. It's about pain, for example. Okay, so you ask someone the question about pain: how painful was your last vaccination experience? All right, and the person answers, oh, I had a little pain. Well, these options, remember, you have to put these options already in the questionnaire. The variable would be pain. The question would be how painful was it in your last vaccination experience? And the options would be no pain equals 0, mild pain equals 1, moderate pain equals 2, and severe pain equals 3. As you can see, these had to be coded for the computer to recognize them, right? But they also have a meaningful hierarchy. So no pain, of course, you can give a 0 because there's no pain. And then mild pain, you could say it's 1. Moderate pain equals 2. Severe pain equals 3. Now, interestingly, what if you started off with no pain equals 1, mild pain equals 2, moderate pain is 3, and severe pain 4? Would that make any difference? Of course not, because they have an inherent meaningful hierarchy, but these numbers don't really signify those hierarchy aside from that the latter one is greater than the first one. Okay, so as long as these numbers are in sequence and one is greater than the other as you go higher, then it's an ordinal level of measurement. Otherwise, if you said this was 5, this was 10, and then moderate pain, you know 13 or 15. Okay, so one good way and one logical way would be to really have the difference of these two in a meaningful difference. So for example, 0 and then comes 1, comes 2, comes 3. But you could also do 5, 10, 15, 20, having a 5 difference. Although those differences would mean almost nothing unless you say that between 5 and 10, all the numbers you have also mean a gradation. Okay, if that doesn't have any gradation or grading meaning, then that gradual increase really of numbers really doesn't mean anything. But okay, so the bottom line here is you have to code them. Okay, the response options are just words, so they are nominal. And point number two, they are in order of numbers that increasingly go high, or it could go even low depending on how you start. Number three, the numbers that you assign, better to have a difference between them that's rational. Okay, otherwise it doesn't really the computer really doesn't even know what's going on in there. So these values, as you can see, are not really fractions, they're discrete, right? Just like nominal variables, the values are discrete. And but the like I said, there's an inherent meaningless continuity. So between 1 and 2, 2 or 3, well, there is a continuity, of course, but does it really make any sense? It doesn't really make any sense. Okay, it's just a hierarchy. That's what it's trying to show. So a little bit more on the ordinal variables. We, taking the crux of it is the nominal level of measurement can be meaningfully ranked and becomes an ordinal level of measurement. If you think about the colors of the rainbow, for example, and this is one of my favorite example, why are they always in the same sequence? Colors are by default nominal variables, right? You're not supposed to even say blue is number one, green is number two. How can you say that? Except for when it is in the rainbow. In the rainbow, or if light passes through prism, they'll always be in the same sequence and they are always in an order. But still, they're words and qualifiers, adjectives, and they need to be coded for the computer to recognize them. So you have red, orange, yellow, green, blue, indigo, violet. This is kind of the sequence, and all of these are coded 1, 2, 3, 4, 5, 6, 7, and they are in order. 7 will always mean a violet, and 1 will always mean a red. Okay, so although they're nominal, in this case, you know, the colors are really ordinal because they have an order, an inherent order. All right. Colors of tablets are nominal, but colors of rainbow ordinal. That's what I mean. Um, so be concerned about the inherent nature of the values and decide about the level of measurement. So religion can never be an ordinal variable. You cannot say, I would like to give Christianity in number 5 and Islam in number 1. No, except if you would like to say that based on the majority faith group, I will code them. Okay, in that case, if a community has a majority faith group of Christianity, then Christianity goes in 1, Islam goes in 2 if it's a second in order, or Hinduism. But otherwise, there is absolutely no reason why you do that. So notice about the inherent nature. You cannot say female is goes in number 2, male goes in number 1. It's nominal variable and there is no order. So these are not ordinal variables. These are purely nominal variables. Okay, that's the difference you gotta make. The next level of measurement is called interval, and we so this is also interesting. We're going gradually from simplicity to more complex, but also from a more non-common sense to a common sense. Okay, so the interval is if the range of possible numbers generated by a variable does not require to be ordered or ranked. Remember that. Okay, although you'll see that this is a very common sense. I mean, it's just written this way because of the academic discussion is mostly done this way. So if you have a range of possible variables, again, they're generated by your questionnaire, and it does not require to be ordered, number one, and the zero, there could be a zero, and the zero among any of those possible values does not imply the absence of something. Okay, now this is very theoretical. You'll see the example. Now the most important one is this one, really. Comparison of two data points are meaningful by calculating the difference, not the ratio. Okay, so you have, you know, you can always compare in two different ways. Either you can compare something as big or small by looking at their difference, meaning subtracting each from the other, or you can compare by a ratio. Okay, how many times greater than something, and that actually has a meaning. Okay, you'll see very interestingly that some of these ratio does not really make sense. Rather a difference makes sense, right? For example, we'll come to that a little bit later, but then look at this point. It can only be used to calculate intervals between 2 points, meaning addition or subtraction. It's really repeating itself, but it's emphasizing that the different or intervals can be between 2 points can be meaningful by adding or subtracting. So here's the example. Zero does not indicate any absence. Okay, usually what we know that zero is also indicative of absence of something, right? But in this case, only indicates no difference or a beginning point on a number line. So it's something like this. Temperature, 0 degrees Celsius does not mean absence of temperature, right? Very common sense and widely used example in lectures for interval level of measurement. 0 degrees Celsius is not absence of temperature. Even 0 degrees Fahrenheit is not an absence of temperature. So this temperature itself here is really an interval level of measurement. That's what you got to remember, okay? Um, However, you'll see later that it really does not always make sense to even have this category interval and ratio that will come later, and they can be merged, which is done in SPSS, because in reality the calculation does not make much difference except for in higher level of advanced statistics. So a little more examples. Two data points cannot be expressed as a ratio, and 40 degrees Celsius is not twice as hot as 20 degrees Celsius. That's what it means. So if it was a ratio, then 40 degrees, which is two times at as 2 times the value of 20 degrees Celsius, would also imply that the heat that you're getting from this is 2 times more, which is not the case. So there is a calculation that says it's 2 times higher, but this 2 times higher does not give you the actual meaning of the 2 times being higher. Okay, the difference between 2 points is meaningful on a number line. That's what I'm repeatedly saying, because that's more easy to show. For example, it also includes direction. Today's temperature will drop by 2 degrees at night from 10 to 8. Okay, 10 to 8 degrees centigrade or Fahrenheit centigrade. That's more common in Toronto, even in the summer days. So look at this. This number line here, it has a beginning point, right? And the temperature was 10 degrees. It will go to 8 degrees. It has a direction as well, and like ratio, it does not have a direction really, unless you flip it and then you say it's less than one or more than one. But in this case, you have a direction. Let's go back. Uh, Sorry about that. So we're in the ratio already. The ratio level of measurement said it has a true meaning of the ratio values. Okay, true meaning of the ratio value. For example, if time taken to dissolve a tablet is 5 minutes and the other is 10 minutes, uh, the first takes half times the second, or the second takes twice the time as the first one. Okay, so that's an example of ratio where the time is measured how many times? 2 times, right? So it actually takes 2 times more. um, all continuous data are either on ratio or interval level of measurement. We had a discussion about continuous kind of data before. Actually, continuous variable, not data. That's what we discussed in the previous lecture. And continuous variable was described um, through an example where a line was drawn and then asked how many points would you need to make this line, and it was like almost countless, and you could have any kind of a fraction in between. So
all continuous data are either on a ratio or an interval level. That's why they say that, there's no really point to divide these two categories. I'll give an example. So here you have a line where you start from here and you go 6 steps. That's a fragment of a line. So this, let's say this is a fragment of a line, and then you go 12 steps around here. Now you have one segment here that's 6, and then to make the next segment you need two of this, okay, two times. That's all the sense that a ratio is going to give you. Okay, so this fraction is half of this, or this one, this segment of the line is twice of this. And this is a continuity, and it has an inherent continuity in itself. So but you could also think of it as an interval level of measurement, right? You just subtract and you say the difference is just one of these bars. That's why it's really something that can be considered together, interval and ratio. In practical terms, in SPSS, when you enter the variable level of measurement, it only has three different kinds of options: nominal, ordinal, and scale. Scale is something that is merged into interval and ratio. So that means and why do they call it scale? And you'll actually see a symbol of a scale when you enter the data, and we'll see that later. The reason why they call it a scale is because you're taking a measurement of a direct number. Nominal or ordinal, you're not directly measuring any numbers, you're assigning codes. If the codes have, and I'm actually going ahead of myself, it's in the next slide. If the code has an order, then it is ordinal. Okay, so this is really one of the practical utility of this level of measurement is during your statistical analysis and entering SPSS, also probably other software. So the message is very simple. First, remember, any value that requires to be coded is nominal. Okay, any so you have again, start from the first lecture. We talked about research question. The research question focuses on a variable. The variable gives you some response options. The response options, if they need to be coded for the computer to recognize it, it's a nominal if you have to assign a number. If the nominal variable needs to be ordered because it has an inherent order, then it's an ordinal variable. Okay, other than that, everything is a scale. So that's a very straightforward thing. What is a scale variable? Anything that's not a nominal or an ordinal variable. How do you know it's a nominal or ordinal variable? Well, you look at if they have codes against them, if a number is assigned to them, if they are a noun or an adjective that was identified by a number, they are nominal and ordinal variables. Other than that, everything is a scale variable. Okay, we'll see later that the nature of statistical calculation depends on level of measurement. Okay, that'll be all for today. Thank you very much, and then we'll look forward to the next lecture.